We want to find a power series representation of this function 2 divided by 1 minus x about c is equal to 0. So what does it mean c is equal to 0? You know that the power series can be written as negative 1 to the k times x minus c, right? And in this case c is equal to 0, so basically the form that we want to use is going to be from 0 to infinity of negative 1 to the k multiplied by x minus c should be to k, so x to the k. Okay, so this is the form that we're going to use to derive a power series representation that will converge to this function 2 divided by 1 minus x for certain x values, for a certain interval. Okay, so you should recognize this given form, okay, this form that we're using as geometric series, okay, because we can write this as this as negative x to the kth power, right? Because both x and negative 1 are raised to the kth power, so negative x to the kth power, geometric series, right? Geometric series that converges to what? To 1 over 1 minus negative x, right? Is equal to 1 over 1 plus x, right? Because the ratio is going to be negative x, right? That's the r. So r, should say just the r, so that's equal to negative x, right? So convergence for absolute value of r, as you should know, right, which is equal to absolute value of negative x, which is equal to absolute value of x, whenever that is less than 1, right? So from that we can deduct that the interval is negative 1 is less than x is less than 1, right? So in any case, this is a geometric series that converges to 1 over 1 plus x for the values for the x values between negative 1 and 1. Okay, so now we're going to use this part, the given, and let's write 1 over 1 plus x. As you can see, it's already pretty similar to 2 divided by 1 minus x, right? Just a few algebraic changes that you need to perform to transform this function into the given function that we must find the power series representation for, right? So let's write this as given, negative 1 to the k times x to the k, right? True for negative 1 is less than x is less than 1, as we just determined. Okay, so now, as you can see, there is negative x here, but in the given one, but so far we have 1 plus x, right? So what we're gonna do 1 divided by 1 plus, and we're gonna replace the x with negative x. So we're gonna do negative x in parentheses. We're gonna do the same replacement in the power series. So we're gonna do negative 1 to the k times negative x to the k, right? We're replacing x with a negative x, right? And true for, and here you have to do one more replacement, the substitution. Negative x, right, is less than 1, which is the same as pretty much the given. Negative 1 is less than x is less than 1, right? Because if you multiply three sides by negative of the inequality, the directions will reverse, right? So, and in the end, you can just rewrite it using the same way, the same method, right? So, now what does that mean? This power series can be actually simplified and written as x to the k for negative 1 is that less than x is less than 1, right? Because the negative 1 and negative x are both raised to the powers of k, right? So algebraically you can multiply them, and which will be the x, the positive x, to the kth power, right? So now what does that mean? It means that we have 1, and on the left side we can make it a simplified version. 1 minus x, right, is equal to this. So now notice that it's almost the function that we want. The only difference is there's a 2 in the numerator. So multiplying this function by 2, we will get 2 divided by, let's write fx because that's what we want, 2 divided by 1 minus x. So we need to multiply the power series by 2, right? So it's going to be 2x to the kth power, true for negative 1 is less than x is less than 1, right? So we need to find the radius of convergence. The radius is going to be half of the distance of the endpoints, right? So the radius of convergence, right? Let's actually find the interval. Well, the interval is already there, right? So the interval of convergence is going to be this, right? We're just going to write open, so parentheses negative 1 comma 1 open, right? Because the endpoints are not included, right? Because in the geometric series the endpoints are not included as we've shown before, right? Okay, so interval of convergence from negative 1 to 1. So now the radius is going to be the distance between these two endpoints, right? So it's going to be the distance divided by 2, right? So absolute value of negative 1, right? Because negative 1 is not a distance, so we must take the absolute value of that, right? Absolute value of negative 1 plus 1, this is positive, so we don't need the absolute value, divided by 2. So that's going to be 1 plus 1 over 2 is equal to 2 over 2 is equal to 1, right? So the radius of convergence is 1, and the interval of convergence, of course, is going to be negative 1 to 1 open interval. So what does this result mean? It means that for the x values between negative 1 and 1, the power series 2x to the kth power from 0 to infinity converges to the function 2 divided by 1 minus x, right? If you graph this, you will see that it's going to fall into the function. Basically, it will merge into this function between the values of negative 1 and 1. Okay, thank you so much for watching. I hope this was helpful, and I'll see you in the next power series video.